Hi, in this series of videos, I'll be solving the free response questions from the 2023 AP Statistics test. Question 1. As part of a study on the chemistry of Alaskan streams, researchers took water samples from many streams with temperatures colder than 8 degrees C and from many streams with temperatures warmer than 8 degrees C. So already you see two populations and samples taken independently from the two. For each sample, the researchers measured the dissolved oxygen concentration in milligrams per liter. We're looking at a quantitative or numerical variable. Part A. The researchers constructed the histogram shown for the dissolved oxygen concentration in streams from the sample with temperatures colder than 8 degrees C. So this is the colder side. Based on the histogram, describe the distribution of dissolved oxygen concentration in streams with water temperatures colder than 8 degrees C. So it's this histogram that they want us to describe. So it's a question about describing a distribution of a quantitative variable. The common approach is to describe the shape, which consists of how many modes, unimodal, bimodal, and the skewness. Is it skewed to the left or skewed to the right? Center, spread, and special points such as outliers. This is the shape. Outliers, center, spread. So many people teach it as SOCS, SOCS, for ease of remembering. I like to put outliers at the end. Describe the distribution. The distribution of, and then we need context. Context is a big deal in AP statistics. So all of this context, put it all in your answer if you can, or if you're tired of doing that, do some sort of abbreviation. I'll just put the whole thing in. The shape, modes, and skewness is unimodal, one mode here, and is skewed to the left. The mode is here, and the rounded number for that is 11. But really, because it's a decimal, so it's really between 11 and 12. All right, now for the rest of the center and the spread and outliers and all that, I can actually compute the mean and standard deviation by converting this histogram into a table. So for example, this bar right here, I would put it in a table of X and frequency of X as an X value of, well, it's anywhere between 2 and 3, right? It could be 2 point something. So the advice that most people give you is to enter it as a 2.5 with a frequency of 1. Over here is a 3.5 with a frequency of 0. You can put it in or you can ignore it. 4.5 with a frequency of 1. 5.5 with a frequency of 1. 6.5 with a frequency of 13, etc., all the way to the end with a 13.5 and a frequency of 46. So you have all the stuff in between here. If instead of 2.5, 4.5, you enter as 2, 4, you probably will come up with an answer that's close enough. Your mean will probably be 0.5 below my mean. Your standard deviation will probably be the same, probably be close enough that it's acceptable. Because even the 2.5 is just a guess. Right? We don't know where it is between 2 and 3, so we guess it is probably nearer to 2.5 than any other number in that range. But it could be at 2.0 exactly for all we know. This approach is a commonly used approach, but it's not the only approach. And it certainly cannot claim to be better than everyone else. So I would put all of that into my calculator. If I were using a TI, it will be 1 var stats with L1, L2. That's for the TI. If I were using the Casio, I'll be setting the X list and the frequency list. And then after that, I'll do calc 1 var. Either way, I would end up with the same answers. And I'd write it down here, approximate mean, 11.1. Standard deviation S is equal to 1.726. That will take care of the center and the spread. I might as well put down the median. And now about outliers. Because I ran the summary statistics, I know what the Q1 and IQR are. So with Q1 equals 10.5, IQR equals 2, thus outliers below 7.5. And there are 13, 14, 15, 16 of them. Part B, the researchers computed the summary statistics shown in the table above for the dissolved oxygen concentration in streams from the sample with water temperature warmer than 8 degrees C. Use the summary statistic to construct a box plot. Do not indicate outliers, so you don't have to do that 1.5 times IQR. The whiskers would go all the way out to the minimum and the maximum. For box plots, I need these numbers. I don't really need these two numbers. I may use them for something else later, but right now I just need those numbers. So 2.1 is around here. Q1 is 4.39, which is around here. Median is 5.43 around here. Q3 6.12. And maximum is at 13.45. Draw my box around the middle part and draw my whiskers out to the min and to the max. Now part C. The researchers believe that streams with higher dissolved oxygen concentration are generally healthier for wildlife. Which streams are generally healthier for wildlife? Those with water colder than or warmer than. Using characteristics of the distribution of dissolved oxygen, justify your answer. Basically, they're saying more oxygen is better. So which one has more oxygen? Regardless of how much calculation you did or did not do in part A, you can still answer this question. Part B basically says that 75% of the sample have oxygen of 6.12 or below. Whereas part A, if you look at the distribution itself, 6.12 and above captures the vast majority of the samples. So even though you may have missed most of the calculations or you didn't think of doing the calculations, you can still answer part C. I will pretend I didn't do any calculation in part A and answer as far as I can see in the graphs. For water colder than 8 degrees C, vast proportion of the samples, and I can just add them up and I see that it's 429, whereas below 7 is just 16. So 429 minus 16 is 413. Have more than 7 mg per liter oxygen. While 75% of samples warmer than 8 degrees C have. And now I'm doing a comparison question. So I need comparison word. Have 6 mg per liter concentration. Here's my comparison word, lower than 7. So that's what I get if all I have are the two graphs, the box plot, which I assume a lot of people can do, and the histogram that's already given. I'm doing all this without any calculation. If I go into the calculation, then I can start comparing other things. Holder mean concentration is 11.1. Higher comparison word. Warmer mean of 5.54. Holder median of 11.5 is higher than warmer median of 5.43. I am not actually gonna run a 2-sample t-test for the means because I don't know the sample size of this sample. I don't know how many of the warmer samples they took. There's nothing in the description. So first of all, I cannot plug in the number for my calculator. And second of all, I cannot check the conditions are met. I don't know if it's more than 30. It's definitely not symmetric. It's very skewed. So I would prefer to have a large sample, and I don't know if I have a large sample. So part C is basically a descriptive question. Actually, I'm going to change the 413 divided by 429 into a percent. Just fix a few wordings here and there. And since I'm giving the standard deviations, I might as well use it. And it's a good idea. If you think in terms of ANOVA, right? You want to show that the two are not overlapping by a lot. Both have small SDs. Decoder, S is equal to 1.1. Warmer S is equal to 1.7. While the difference in mean is this mean is actually 11.1 actually. So difference in means is 5.56. I want a comparison word more than 3 times either standard deviations. So very little overlap. So this, I've used all the information that I can. I feel good about my answer. Now I have to answer the actual question asked. The question asks, which streams are generally healthier for wildlife? I have to answer that. Because colder streams, I'm adding more words now because I really want to put in a lot of comparison words. More oxygen generally. I'm using the word generally because it's in the question. Colder streams are generally better for wildlife. That's question 1. Check the description section for the solution to other questions. Any questions, or especially if you think I'm wrong on something, please write in the comments. Subscribe for more contents. Check out my statistics playlist for more videos. Thanks for watching. Bye.